So I'm going to be talking about using JavaScript to teach machines how to do not just basic shit, but cool, not just basic things, but cool shit. So we'll just jump in. My name is Kylie Stewart. I work for Formidable Labs. You might actually know us through our open source work like Radium or Spectacle, which is actually what I'm using to present this right now. And long story short, we are hiring, so if you want to talk about life at Formidable Labs, I am here to talk. So today, these are some of the questions that I am going to be answering for you. We have, how is machine learning different from artificial intelligence? Just the high-level overview. What are some different learning types, and how can we apply those to those machines? How do you decide which learning type you actually should be implementing? And seriously, can we do this in JavaScript? Not sure. So we'll just dive right in. What is machine learning anyway? So you hear about it all the time. We interact with it fairly regularly, and it's easily inferred from the name. You're teaching machines to learn. We've had access to it for a while, but the data sharing and the collaboration is key to actually getting artificial intelligence to where it needs to be considered intelligent. So shared knowledge is definitely a huge part of implementing artificial intelligence, but to define machine learning, Arthur Samuel coined the phrase as the ability to learn without being explicitly programmed. So it's teaching machines how to learn themselves because it's definitely not something they can do on their own. So think function notation. You have a list of inputs X, a list of outputs Y. Normally we'd write that function just so we know how to get from X to Y, but with machine learning, we're training that machine to approximate the function that converts X to Y instead and on our behalf. So we really want to interrupt this process where the input still exists, the output still exists, but the mapping from point A to point B is what needs to be determined. So it's important to note that machine learning paves the path to artificial intelligence. As I mentioned, artificial intelligence does have a ways to go. That collaboration is a big part of it, but we need the machine learning to be working in order to gain the artificial intelligence, as you can probably assume. So how do we do this? There are a few different ways, but one of the types is supervised learning. The biggest thing to note here is humans are involved in it. That classroom image is probably the best depiction. We have humans teaching machines. They need to know what's important, what's not, things to neglect, things to include. They really need guidance because on their own, they aren't as easily able to make those kinds of inferences. By contrast, there is unsupervised learning, which a human's not as much involved, but the machine itself is able to set out on its own, given a set of loose constraints, and go make some determinations, like clusters of data that are all similar, or anomaly detection, things that are extraneous to the average span of data. So in short, a good way to understand the learning types themselves is looking at the actual data that they consume. Discrete data versus continuous data are going to have vastly different applications in the algorithm. So with supervised learning, for example, and some discrete data, a classification algorithm would easily coordinate this color with this object. So maybe you always want to know that apples are red. A classification algorithm is a good way to do that. It's important to note, however, that discrete data being individual points doesn't allow for the same type of content. So behaviors over time are something else that you would want to consider, which by contrast to a supervised learning technique of linear regression, you have continuous data. There are multiple types, wide-ranging values that could be assigned to that data, and a regression technique does a really good job of working with a range of data versus the exact definitions and trying to fit things into a box. Probably the best way I can define that there. On the unsupervised learning, as I mentioned, clustering and anomaly detection being two main methods of unsupervised learning, it's easy to file those into the system where in discrete data, clustering is looking at very specific data points. If it is within this defined realm, it's easier to obviously define that data. So moving forward, let's start with not so smart Twitter bot. This is not really doing anything, and the code behind it, if you can read that, is really just grabbing tweets by a hashtag, picking out a random one from that array of values returned from the Twitter API, and then actually running the function. And that's set to an interval, so that's every few minutes. But very basic, very dumb, not making decisions on its own, and we aren't teaching it anyway. So how can we make this smarter? What would be a good thing to do to make this Twitter bot actually do something better? Maybe we want it to classify. So defining smart in this context would be, maybe I want this Twitter bot to actually take technology, any instance of the word technology in Twitter, and file it into certain categories so that I can maybe feed those tweets out to someone else. It's like a smart aggregator. So would clustering be good for this? Probably not. I don't think any unsupervised method would actually be good for this because we do want to give it guidance. Therefore, we can probably rule out both clustering and anomaly detection. Regression, it's probably a good consideration. Wide-ranging values, I don't know if we would classify tweets as having wide-ranging values, but if you take a step back and consider the human language, maybe that is something that we want to consider. How does human language develop and interact with these keywords? Classification, I think for this example, that would be a pretty solid bet. We can try to classify these tweets just based on instances of parallel terms. So we're thinking of the word technology being thrown out there, and we're thinking of ways to actually implement one of these algorithms. When talking through those algorithms, we also have to consider the trade-offs. What are the advantages or disadvantages to picking a certain algorithm? So this bias variance trade-off is distinctly referring to the desired outcome and how that outcome can be affected by the algorithm type. So with variance, it's referring to the sensitivity of the data set. So how much value is going to be put on an independent variable in that data set, and how wide-ranging is that data set is where bias comes in. So you want to know how diverse is the data set that's going to be used to train this machine, but additionally, are there wide-ranging values of negative, positive terms, varied outcomes? You want to give both positive and negative feedback to a machine, anything else that's learning, because you want to know, as I mentioned, that guidance is key. So naive Bayes is the linear classifier I'm going to use for this example. It's pretty straightforward. It calculates probability. So really, you're weighing the opportunity of, or not the opportunity, you're weighing whether or not this outcome is available. So what is the probability of an association? So I'm going to step a little bit further into this, and this GIF is from a Wendy's commercial, if you were wondering. These are the categories I'm going to define, and I'm going to tell my classifier to just throw out all other value. If you see something that doesn't really fit into any of these, if the probability is lower than 50% for any of these values, then just dump it. Just don't save that tweet to anything. I don't want to curate a list of anything because that tweet doesn't apply to my 4 categories. So looking at these categories, and we want to look at instances of like coordinated association. So given that we have just environmental, programming, space, sports, combined with technology, and every instance of that in Twitter is obviously vast. So on the initial run of my naive Bayes classifier on this, we get this falsely coordinated tweet. So it's important to get more women into the text-based technology. It's too important to be left to men. Not really about space, and that's where it fell into. I don't even know if I would classify this as programming, but it is certainly a distinct tweet that is hard to define, which kind of circles back into why would you, not why would you, but the discrete versus the continuous data issue. Human language is distinct, and I think the instance of space in this capacity is hard to analyze for context. So if maybe we use a different type of algorithm instead of this naive Bayes classifier, if we were to use a linear regression system, it might have actually picked up on that context of text space not being associated with space. So now that we've stepped through just the very basic implementation of a supervised learning algorithm, this is a little bit more of a deeper implementation of unsupervised learning algorithms, which deep learning. So stepping forward a little bit more. Back then, we're looking at deep learning in the form of Deep Blue. This machine was programmed to identify every possible chess move, as we're all probably very familiar with. That is considered a neural network because every possibility was defined. However, it is not like a true neural network. And neural networks, as I mentioned, that data collection, that shared data over time is really important. So this is the implementation of neural networks today. You can use them for quite a few things. Training a neural network on Red Lobster tweets probably won't turn out so great. I think this is hilarious. The actual instances, if you were to look further down, are great. It's just apologies all down the line. So we're looking at the two different types of neural networks, and you've probably heard these before. ANN versus CNN. What is the main difference? The artificial neural network is going to be the same, really, as a convolutional neural network. The difference being that a convolutional neural network explicitly assumes that the data it is going to be provided is an image and nothing else. It is able to make separate processes, different connections by that. So moving forward further, we have all of these. This is the basic neural network if you were to break it down into figuring out those layers. A neural network is really meant to make the same connections that our human brains do. So in a human brain, we're able to connect with prior experiences, with other interactions and other trainings that we have had prior. There are other layers that abstract out, that affect our processing and the way that we're internalizing anything that we learn. So a neural network, in its attempts to mimic that behavior and that extra processing, all of these hidden layers come into play. And there are a few different types of layers. You have your convolution when it first hits, if you're moving from the diagram this way, and everything gets pulled down to a final output, which is where your neural network is actually giving you that output. So now that I have thrown a whole bunch of neural network data at you and definitions, the biggest thing to take away here is, can we do it in JavaScript, and why, and how? And I've heard that you shouldn't, so should I really do it? The biggest reason that you might want to not do this in JavaScript is you'd be reinventing the wheel. A lot of these algorithms are very classic and easy to implement using Python or a language that is more adapted to a larger data set, but JavaScript in particular, this allows us to implement it in all sorts of other functionality and existing applications. So there are a lot of libraries that allow you to do this and that make it easier to access that. So I wanted to shout some of those out. I have my Twitter bot on GitHub currently, and if you wanted to open up that code and look at the naive Bayes, then you will actually see I've implemented a neural network to generate tweets based on the data set of the collection. So the takeaway here is go check that out on GitHub if you want to see it in action in JavaScript. But it's easy to actually access these methods in JavaScript. It's easier than we assume, and thank you.